Hello Legacy Mathematicians, Marsh here. So today we're going to start our very first day of my favorite F word, factoring. Love factoring. And you will love it by the end of this unit too. So today we're going to factor out a greatest common factor, the first type of factoring. What you're going to want to have on you today is your notes, and then you may need a calculator to do some quick division. First kind of thing, we're just going to talk about what we've done before. So greatest common factor, guys, is basically the biggest number that can come out of two different things, or the biggest number or biggest term that you can take out of both things. Now, you've done this when we were simplifying fractions long ago. So when you would want to simplify a fraction, you had to find the biggest number that would come out of the numerator and the denominator, right? Well, same thing. Let's jog our memories of how we did that. So I want to find the greatest common factor of 45 and 36. So very first thing, 45. I need to know the factors, aka the numbers that when I multiply I get 45. So if I multiply, well, first things, I know 1 and 45, right, will give me 45 if I multiply. 2. 45 divided by 2, that's not a perfect number, so 2 is not a factor. 3 is, though, right? Because 45 divided by 3 will give me 15. 4 can't go in, but 5 will. 5 and 9. 6, 7, I think that's all. So now, let's go ahead and find 36's factors. So very first thing, 1 and 36. 2 and, what's 36 divided by 2? 18, right? 3 and 12. 4 and 9, that's another good option. And then 6, right? 6 times 6. So now, guys, the greatest common factor is basically, what numbers do these guys share? Well, they don't share 45. They both share 1. It looks like they both share 3. And it looks like they both share a 9. Now, we want the greatest common factor. So we want the greatest number. So our GCF, greatest common factor for short, is 9, because they both share 9, right? Let's do the same thing with 18 and 42. So 18, I have 1 and 18, 2 and 9, 3 and 6, right? Because 3 times 6 gives me 18. 42, we can use 1 and 42. We can do 2 and 21. Does 3 go in? Let me check here. Oh, yeah, 3 does go in. 3 and 14. And then 4 doesn't go in, but 6 does. And that would be 6 times 7, right? So let's circle our common factors here. We got 18. No, 18's not in there. Silly Marsh. Let's erase that. It looks like 1 is a common factor. It looks like 2 is as well. 3, and then 6 as well. So my GCF between these two, it looks like it's going to be 6, because 6 is the largest number. Now, what we're now going to step on to is finding the greatest common factor between terms in a polynomial. So basically you want to think to yourself, what can I yank out of each term, or what does each term have in common? That is the question that ultimately you're asking yourself. Oop, each term have in common. Kind of like how the first one we found what factor they had in common. Now, the first thing you can start to do before you're getting comfortable with it is you can basically expand this. So x cubed, that is basically 3x's, right? x times x times x. So 5x squared would be 5xx, and then this is just 3x. Now, if we look here, what do each of them have in common? Well, it looks like they all three have only one x, right? Because this guy only has one x, so we can only take one x from each of those as well. So my greatest common factor of all three terms is just a simple x. Now what you're going to want to do then, guys, is you're going to want to figure out what is left behind. What do you leave behind when I take that x and divide it away from each of them? So basically, if you notice, I have two x's left behind for that term. So x cubed, if I divide by an x, I am going to get x squared. 5x squared, if I divide by an x, we're just going to get 5x left behind. And then 3x divided by x is just going to be 3. That is where we're going to leave this problem. I have found my greatest common factor, x, and I have found what would happen if I divided out the x. Now notice, guys, you could distribute this x back in and you would get back to here. That is what's so wonderful about factoring, is you always can check your work. You can always make sure you're always going to get 100% on this information. Let's try it on this one. So x to the 5th. Remember, guys, that is 5 x's here. And then I have 3xx, right? Well, if you look between these two, this guy, he looks like he has 2 x's to give, and so does this guy. So it looks like I can take out a greatest common factor of xx, which in shorthand we can write as x squared, right? So if I divide out an x squared out of this, basically removing 2 x's, I'm going to have 3 x's left behind, which is just x cubed. Same thing, if I divide by an x squared, I'm just going to be left with a 3. So my answer would be x squared times x cubed plus 3. Let's try a couple extra here. So, very first thing, let's try to kind of take our way out of expanding everything, because that's going to take a while. Let's look first at the numbers. So I got a 4 here, a negative 24, and an 8. What number does 4, negative 24, and 8 share? And we want it to make sure it's the biggest number. So I'm going to think here. 4 has 1 and 4 and 2. 24, 1, 4, 6, 2, 12, stuff like that, right? And then 8 is 1, 8, 4, and 2. Sounds like the biggest number I said was 4 on all of them, right? So I do notice I can divide away a 4 out of each of these guys. Now let's pay attention to the x's. So this guy has 5 x's, this guy has 3 x's, and this guy only has 1 x. So the question, remember, we ask ourselves is, what do they all have in common? So they all have in common 1 x, right? Each of them have at least 1 x. So let's say we divide or pull out that x value. So I'm going to pull out of each of these terms a 4x. Basically, you're dividing by 4x. So if I divide 4x to the 5th by 4x, notice my 4's are going to divide out. X to the 5th over x, well, that's just x to the 4th, right? Because when you divide bases, you're going to subtract the exponents. Let's do the same thing. Let's divide by 4x. So negative 24 divided by 4, that's negative 6. X cubed divided by x, that's just x squared. Same thing. Let's divide this third term by 4x. So 8 divided by 4, that is 2. And then my x's are just going to cancel off. Now, let's do multiplication. Let's make sure it's going to come back out what we wanted it. So 4x times x to the 4th, that is 4x to the 5th. 4x times negative 6x squared, well, 4 times negative 6 is negative 24. X times x squared is x cubed. And 4x plus 2 times plus 2 would be a positive 8x. Notice, guys, how these match. That's good. That means I did factor correctly. That's something you don't need to do. You can do it in your head if you want at the end of each problem. But like I said, it's a very nice thing to be able to do. Alright, let's look at this problem here too. What number does 9, 15, and 12 have in common? Not 5. Not 4. What about 3? Yeah, they all have 3 in common, right? So let's take out a 3. Let's divide by a 3. And then let's figure out how many x's can I yank out of each of these guys. How many x's do each of them have to spare? So I have 6 x's here, 4 x's here, and 2 x's here. How many x's? What's the most number of x's I can take out of every single one of them? Well, it looks like I could take out 2 out of every single of them, right? Because they all have 2 x's. So it looks like my GCF of this particular polynomial is 3x squared. Let's figure out what's going to get left behind when I divide out a 3x squared and take it out and put it out in the front. So 9 divided by 3, that is 3. X to the 6th over x to the 2nd, well, subtract 6 minus 2, that is x to the 4th. Same thing, let's divide by 3x squared. 15 divided by 3, that is 5. X to the 4th, x to the 2nd, it looks like we're going to have x to the 2nd left behind. And then 3x squared, 12 divided by 3, that is just a 4. And then x squared over x squared, gone. Quickly in my mind, I'm going to multiply here. 9x6, 15x4, 12, x squared. Perfect. Works out. So that is the first version of factoring that you've been exposed to. It's the first thing we're going to want to do in every single problem. So we're going to want to get really good at GCF finding because, guys, it's going to make your life a lot easier when we get into higher levels of factoring in the later of this unit. But with that, that is the end of this video. See you later, Sabers.